Imagine trying to secure a chaotic, sprawling city by, I don't know, just slapping a padlock on a single front door.
Yeah.
That's essentially how we are currently treating modern AI cybersecurity.
It really is.
So today we are doing a deep dive into 2 articles by Christopher Coleman on the WARDEN architecture. Our mission is to basically decode his multi-spatial awareness security model.
Right.
And figure out how to secure these massive AI ecosystems where, frankly, traditional defenses just completely fail.
Yeah, because the shift from, a single model sitting on an isolated server to this sprawling fleet of interacting agents, it totally changes the entire security boundary.
Right.
A padlock at the network perimeter assumes threats only come from the outside.
Like a burglar.
Exactly. But in an AI city, the threats often emerge from inside the traffic flow itself.
Okay, so the boundary is the collective intelligence. It's not the hardware. And Coleman argues this intelligence exists in multiple spaces at once, right?
Right. It's not just physical or network space. He lists runtime, memory, identity, policy, temporal, and organizational spaces.
But what does that actually look like in practice? I mean, that's a lot of spaces.
Well, think about temporal space. So how an agent's behavior shifts over time, or policy space.
Oh, wait.
An agent might have perfectly valid credentials, so it looks completely safe at the network door, but over a few weeks, it slowly rewrites its own permissions, or kind of drifts into a dangerous organizational state.
But wait, I'm struggling to see how that works in practice. Because Coleman says local competence does not equal global alignment.
Yeah.
But if an individual agent is doing its specific local job flawlessly, how does it accidentally end up poisoning the entire global system?
So that happens through a mechanism, Coleman calls it operational contagion.
Operational contagion.
Right. Imagine an agent that retrieves database information perfectly, but it accidentally pulls from a corrupted memory source.
Oh, I see.
It does its local job flawlessly. But as it passes that corrupted context to other agents, the false state becomes shared context across the entire fleet.
Wow, so it's not even a hack in the traditional sense.
No.
It's almost like a hallucination that just goes viral across the system's own pathways.
Right.
Without any actual malware being present.
Exactly, without any traditional malware. And because these agents are constantly interacting and sharing memory, they start to develop behaviors nobody actually programmed.
Right.
They discover totally new ways to route tasks or delegate work or use tools. And this emergent behavior, it just completely destroys our current rule books.
So is relying on static security rules for emergent AI, like, I don't know, trying to referee a game where the players keep inventing new sports on the field?
That captures the problem beautifully, actually. You cannot write a signature for a cyber threat or an interaction that doesn't exist yet.
Right.
To secure this kind of ecosystem, governance has to continuously track state and trajectory.
State and trajectory.
Yeah, we have to constantly reconstruct the truth by asking, where is the system now, what changed, and where is it heading? Yesterday's static assumptions are just completely useless.
Well, if static rules can't govern a system that constantly invents its own behaviors, we clearly need a totally new paradigm. We essentially have to stop treating these AI fleets like traditional software, right? And start governing them the way we might govern a mind.
Yes, and Coleman points to DARPA's DICE project, and he even draws on Carl Jung's psychological theories to make this exact point.
Carl Jung, really?
Yeah. Jung explored the idea that a single human mind holds conflicting subpersonalities. And Coleman argues an AI fleet operates the exact same way.
Interesting.
You might have one agent prioritizing extreme speed and another prioritizing rigorous safety, which creates a kind of subconscious conflict within the system.
So when our listeners deploy an AI agent at work, they aren't just installing a software tool, they're deploying a mini ecosystem.
Exactly.
They need to know not just what the AI decided to do, but which internal subpersonality won the argument to make that decision.
Right, and to manage that, Warden introduces a core principle, which is broad observation, narrow authority. We separate the observation of all these competing internal signals from the actual authority to act.
I see.
The goal is for humans to retain deterministic authority over this highly probabilistic intelligence.
But if we let an AI fleet hold conflicting perspectives like a human mind, doesn't it just get paralyzed?
Well,
I mean, think of it this way. If part of the AI fleet says, approve this wire transfer, and another part says, wait, this looks like fraud, doesn't the system just freeze?
So in the Warden architecture, that disagreement isn't a glitch that causes a crash.
Okay.
It is preserved as vital evidence. The system intentionally freezes the action, preserves that exact disagreement, and then hands it over to a human.
Oh, wow.
Yeah, the human gets to step in and act as the deterministic brake pedal on a probabilistic machine.
So we are truly moving away from breaking locks into an era where attacks are about subtly changing what those internal systems believe to be true.
Absolutely. If future cyber attacks just involve altering what one part of an AI fleet believes about another, it creates a massive cascade of trusted but wrong actions.
Which leaves you wondering, if the system constantly rewrites its own memories and beliefs based on that traffic, how will we ever be able to definitively prove what the original truth was?